Welcome to class today. Plan today is just to go over kind of the procedures for the exam first, and then I'm happy to open it up and answer any questions you might have. So I kind of just want to go through what you're allowed to use, what you're not allowed to use during the exam, how you're going to be submitting stuff and all of that, just so we clear up any of that confusion. So on Wednesday, we can just focus on the exam. So your first page, let me share a different screen here. Okay, so what you're looking at over here are kind of some of the code as far as what you're allowed to use and not allowed to use. These were the instructions for my Math 3000 exam, so the times are off a little bit, but you're going to be allowed to use the same types of materials and not allowed to use the same types of things on this exam. So you can disregard the part about the exam being from 2 to 3:15. Our exam will be administered on Zoom during our class time. So we'll be here, same Zoom room, 11 to 12:15, with your cameras turned on. So during the exam, yeah, that's kind of the expectation there. And so you're welcome to use your own notes during the exam, but I'll just say you're not allowed to use anything that you didn't create. So that means, answer keys are my work, so you're not allowed to use those, but you can use your own answer keys if you want to during the exam. You're allowed to put together a study guide. You're not allowed to use the textbook. You're not allowed to use any materials that I've created, and you're not allowed to use the internet during the exam. So the only thing you're using the internet or any technology for is to get on Zoom and to get onto Canvas to get the exam materials. You are welcome to use a calculator during the exam. So that's the only technology that you're allowed to use. So yeah, and definitely this is not group work. So you shouldn't be talking with anybody else in the class or anybody else outside of class. I'll be on Zoom. And so if you do have questions during the exam, as far as like, can you clarify this question, you're welcome to chat those questions to me during the exam. So before I get into how you're going to see the exam and how you're going to submit your answers to the exam, any questions about what you're allowed to use or not allowed to use during the exam? Okay. And if they occur to you later, just let me know. Okay, so then let me show you where you can find stuff. So everything is going to be administered on Canvas. Wrong class. Here's our class. So up here, this is my view, but if I go into student view, you can see these links right now. You can try and click on them all you want. You won't see anything there until the day of the exam. If you do see something there, please let me know. So when you click on this, it's going to say, okay, this is locked until 5 minutes before the exam starts. And same for this one. So this one will open much closer to when the exam starts. So there's going to be two parts to the exam, as you can see. There's going to be a multiple choice part and a short answer part. The multiple choice part, I'll give you 25 minutes. I would say the expectation is that they would take about 15 minutes. There should be really short, quick response questions, similar to the reading assignments that you've had, the Canvas quizzes there. So the idea is hopefully you can get through those in a reasonable amount of time and then spend the rest of the class on the short answer part. Those questions will be more similar to things that you've had on homework and things that we've worked on in class, in the sense that you'll show your work. If you make a careless mistake along the way, you might not lose any credit. You'll get partial credit and stuff like that. For the multiple choice, obviously each question would be all or nothing. So when the exam starts, the idea is that you would start with the multiple choice quiz. You'll open this up. You'll have one attempt on this, so just be careful. On the reading quizzes, you have multiple attempts. You have 2 attempts. So on this one, just make your 1 attempt count. And then you'll head into the exam. Let me get out of student view. And so the exam is going to have these instructions over here with the right times. When it's exam time, right over here where it says coming soon, you'll have the usual link to a PDF version of the exam. So you can download the exam, there'll be space on the exam if you want to show your work on the exam. If you want to write it on notebook paper and take pictures and upload it, that's fine too.
With this part of the exam, it's okay if we use our phone to turn it in and take pictures and do it on the doc? Yeah,
so as far as the technology goes, yeah, you have to use Zoom. You're allowed to use a calculator, and you're gonna have to use Canvas, so that's okay, but you shouldn't be using any other websites from Canvas. And when it comes time to upload your exam, yeah, certainly if you wanna use your phone to take pictures and upload them, totally fine. Yeah.
And since we're on Zoom, I don't know if this will happen, but it sometimes takes a few minutes to download the Google Doc and stuff. So if we if we're a few minutes late, but we're talking with you on Zoom, hey, I'm finishing it, but it's taking me a bit to turn it in, what will that look like?
Yeah, I'm not trying to be a jerk here. So yes, I understand that everybody, these are not normal situations, and so things might happen. And yes, I would just say, if it does happen, hopefully it doesn't, whatever it might be, technology issues, some catastrophe happens at home while you're taking the exam, something, yeah, the more you keep me in touch, the better, the easier it will be for us to find a solution that works for both of us. So if something should happen during the exam, just either if you're on Zoom, chat me. If you can shoot me an email, you can do it that way. If you don't have a connection, try and get on a phone and at least just shoot me an email or something like that. So one thing I might suggest people do is download the Zoom app on your phone. And as a backup, if you lose a signal, you could always contact me that way, using a data plan or something like that. So yeah, hopefully nothing goes wrong. I will say I did the Math 3000 exam last week and it went fine without a hitch. So that was really good. So let's hope for the same here. I'm sure that something will pop up at some point during this semester, and I'm flexible as long as you keep me informed. If I don't find out about it for 5 hours, then there's not going to be that much that I can do. Yeah.
The other question I have is, will we be having to draw any slope maps on this written exam?
You won't have to draw any slope fields by hand, but you should expect to have to interpret them or know how to use them to approximate solutions. Yeah.
Yeah, but we won't have to draw a thing with the slope thing or something like that.
No, but if, for example, you're given a slope field, then you could draw some possible solutions in that slope field. Yeah.
So, that's what we're gonna have to do on the written?
Maybe, I don't know.
I just found it really hard.
The question was, are you going to have to draw slope fields? And the answer is no. Are slope fields going to be on the exam? The answer is probably yes. So you'll have to either read them, interpret them, do something with them. Yeah.
Okay, but I find it hard. Or for me at least, it's going to take a while to draw draw a line on the slope field.
Okay. Yeah.
I don't know if that makes sense. I don't know if that makes sense.
Well,
especially with technology,
we can just be in touch during the exam. Yeah.
Okay.
So just to get the just to check the procedure, the first 25 minutes would be the multiple choice, and the remaining 50 is the written part.
So however long it takes you to finish the multiple choice, the written exam will be open at 11. So once you finish the multiple choice, you could just jump. You don't have to wait the 25 minutes to start the written exam.
Okay.
So if you finish the multiple choice in 10 minutes, then you've got the whole rest of the time to do the written part, for example.
Okay.
Let's see, I think I got one in the chat, a question. Sorry, where's my chat? A couple in the chat. So if you wanna, I'm trying to find my chat. If you've got some questions, okay. So what about the study guide? What about it? Sorry, there was a question about that. You're welcome to use your work on the study guide to help you during the exam, but you are not allowed to use my work if that's the question. You are allowed to use an iPad for the written portion. Yep. However you want to submit. I would just suggest doing it the same way that you've been doing your homework if you've got that system worked out. There's not really any issues that I've seen with people submitting stuff so far with their homeworks. So yeah, just try and keep in mind the neater, the cleaner it is, the happier your grader is. I'll be the person grading your exams. So I'll do all the grading on this myself. If you finish early, do you stay in the Zoom call? I would say, like, if you finish in 20 minutes, then I might not let you run out just yet. If you finish 10 minutes early or something like that, then you'd be free to go. Yeah.
So just to clarify, for the review problems, for the exam, we can use those for our exam?
You're welcome to use any of your own work.
Okay, so
Yep.
we can use our notes is basically what I'm getting. Okay.
Yeah, I would suggest that it's a double-edged sword in the sense that this is a timed exam. So my suggestion to you would not be have an entire stack of stuff here and that you're like digging through it during the exam. You will run out of time if that's your plan. So I would suggest just having a really concise one-page study guide. That would be my advice to you, so that you don't have to sift through a whole lot of things during the exam. So I think it's a good study mechanism anyway to try and summarize the main things down to a page of useful material. Yeah, but that's for you to decide. I'll just say that that is the risk that you run if you don't try and condense your work into some place where things are easy to find. You might run out of time. Yeah. Okay. Any other questions? So I think that was my plan for what I wanted to say about the exam. So if you have some questions that I didn't address, please just let me know.
I was going to ask, so you want it submitted as like a PDF, right? No other sort of file?
If you want to do a Word doc, that's fine too. Yeah, PDF or Word doc. So if you're going to take a bunch of pictures, then I just ask that you don't upload separate JPEGs, but you just scan them into a
Combine them
single
into
PDF.
one? Okay.
Yeah.
And is that a person standing behind you, or is that just just there?
Is that a what?
Person standing behind you, or is that just like a rug?
This? No, this is a piece of exercise equipment that I'm trying to hide. Okay, anything else? Okay, so I did put some slides together. So I just wanted to go through the kind of what material is going to be on the exam. I don't have any examples planned to go over. So if you do have any questions and you want to review some particular material, that's okay. I'm happy to answer them. But let me just kind of quickly go through the scope of what content is on the exam, give you a chance to ask about those sorts of questions. And so the document that I'm going to share with you in a second is posted in Canvas as well. Okay, So just kind of going through this essentially in order of which that we covered things. And the first would be the skills that you hopefully brought into this class. I realize on this slide I spelled integration by substitution, which is not an actual integration method. So the kind of three main methods are integration by parts, integration by substitution, and integration by partial fraction decomposition. So I'll just say that when there are problems, when the integration is not extremely straightforward, please do show your work, show all of it. So I want verification that you're doing your own work, and so that's why I want to see your work. In addition, if you get a wrong answer, it's a lot easier for me to see how big of a mistake you might have made. And if it's really minor, you won't lose many points or any points. So the more work you show, the easier it is for me to give you credit for that. So I'll just say, like, my mindset is not to go into these exams and think about, haha, you know, how can I take credit away from somebody? It's quite the opposite. It's, okay, what can I give them credit for based on what they're showing me? So the more stuff you show, the better it is, as long as it's nice and cleanly organized.
So there's going to be like partial credit.
Yep, on the written stuff, yes. Yep. So the majority of the exam will be partial credit, yeah. So what I mean by this is, you know, if you're integrating this, there's not much to show other than, okay, this gives me sine x plus c. Okay, you wouldn't have to show anything more than that. If you're integrating something like this, and all I see is an answer, then you wouldn't earn any credit for that, just to be really clear. So what I'd like to see is, okay, I'm using, for example, integration by parts, and I'm going to set this equal to x, this equal to cosine x dx, and I want to see all of that stuff. Okay, any questions? So it's not necessarily that you'll have a question that just asks you to do some integration, but of course, when we're solving differential equations that involve that we are required to do integration, it's very likely that you'll have to use some of these, if not all of these techniques at some point. Okay, so just let me know if you got any questions. Feel free to interrupt. Okay. So there's a module called, I think it's called like integration review in Canvas. So there are plenty of, probably more than you care to try, problems to practice. But I think it's really important to get correct and efficient with these methods. The more efficient you are with it, better your time management will be.
With partial fraction decomp, will there be any like special cases? And could you just like go over a few special cases, like repeated roots or unbreakable? Do you know what I'm talking about?
Yeah.
Will we have to worry about those at all?
Yeah, maybe I can hold off on that until I've kind of just spun through all of the material, and then we can go back and take a look at specific things. Yeah. Okay, so yes, you're going to need to know how to integrate on this exam. That's the point there. And so don't discount reviewing those techniques. And then kind of we started with classifications of differential equations. Is it linear? What's the order of the differential equation? Those types of questions. These are very easy to put into multiple choice types of questions, like select all of the equations that are linear or something like that. So just go back. You had some problems, I think, on the reading quizzes that had similar things. So I would say give those a check, and there certainly were some of those on the first homework assignment as well. Okay, and then before we actually talked about how we can solve differential equations. We just discussed what does it mean to be a differential equation, and we had some questions about verify that this is a solution or so on. So definitely be prepared for that. This was a problem that was on the homework assignment, first homework assignment. I think this was one of the trickier ones because it involves some implicit differentiation. So it might be good to just go back, as well as practicing your integration, practice your differentiation. And for the same thing, when definitely provide supporting work when you're showing your derivatives, as well as you're doing with your integration. Okay, and then we started thinking about approximation methods first. So we talked about, and there was a question about slope fields. And so here's a question, for example, with slope fields. You might be asked to do some matching problems with slope fields and things like that. And so with slope fields, kind of the important thing here is right there, kind of the guideposts for our solutions. So if I want to draw a solution in, if that's the question, then we would kind of just follow these things over here, and we might have a solution that looks like that. Yeah, and so if I ask this, I don't know if I will or if I not. That's the fun of an exam. Don't want to ruin the surprise. And you're having troubles from technology-wise, like scanning a solution like this, then you can just let me know during the exam. And if it takes you a little bit longer to upload your work on just that one problem, it's okay. And kind of looking at this differential equation, just some things that were useful to recall is that in this case, we can determine that this is an autonomous differential equation. Since we can see that we have the same slope for a fixed y value. Different x values. No, I'm sorry, that's not true. When we go across, no, never mind. This is not autonomous, right? Because when we go across that line, the slopes are different, right? So that would be a good indication that this should depend on x, and it should also depend on y, this differential equation. So these are some good things to ask yourself as well when you're looking at these. That would be a good multiple choice question, right? Does this differential equation depend on x, depend on y, both x and y, that sort of thing. Okay, any questions? Okay, and then kind of related to this graphical approach is kind of how we can make this into more of a numerical sort of problem. And so, yeah, that technique was Euler's method. So definitely review that method. If I ask you to do Euler's method, I'm not going to ask you to do 10 steps of Euler's method. If you can do 1 or 2 steps, then clearly you've got the algorithm. So that's at most that you would have to do.
Yes, I want to ask, have you posted the answer of this question, or we will go through of it?
Sorry, I missed that. What was the question?
No, have you posted the answer of these questions, or we will go through of it?
So some of these were on homework. The point here is just to use these as illustrations of what I mean by these sorts of questions. I'm not going to put solutions up for this. There are like 1,000 problems. There's the whole review guide. So I don't think there's anything in these slides where something similar is not asked in the review guide. So I just want to use these as illustrations of what do I mean by that. Yeah. Okay, so then in sections 1.3 and 1.4, we learned about separation, separable differential equations, linear first order differential equations, and using integrating factors. So there could be multiple choice questions that are And you've had some of these on the reading quizzes, like, is this separable? Is this linear? Is it both separable and linear? And so on. And of course, you'll have some short answer ones where you actually have to solve it. Then we talked about equilibrium, autonomous differential equations. I think this was from a homework assignment, actually, maybe the first homework assignment. Phase line. And so this is the business of, finding equilibrium. And then based on I'm just making up a random picture here, but like based on the signs of the derivatives, adding some arrows and then being able to determine whether equilibrium are stable or unstable and what the practical ramifications of that are. Okay. Then we took a look at applications of these first order differential equations. So the applications that we definitely took a look at were population models, both the Malthusian one, which doesn't take into account the death rate, and the logistic one, which does take into account the death rate. We did mixture problems like salt tank problems. And there were some other applications where maybe you were described what the rate of change is, and then you had to come up with a model based on that description and solve it and so on. So there will be some applications certainly on the exam. This is an example of one that maybe I think we might have done something very similar to this. And so some of these take a while, and so that's on me to kind of balance how deeply I want you to go in to solve these problems versus just setting them up. So just be prepared to set them up and to solve some of them. Okay, any questions? And then I don't have much to say about this since we've been doing this the last couple of weeks, but yeah, second order differential equations, homogeneous, non-homogeneous. You can definitely expect to get a number of questions that are just asking you to say, what would the guess be if this were the setup? And then you'll have some that are actually going to say, go ahead and solve for the undetermined coefficients. So just be sure you read directions carefully on the exam as far as whether you actually need to go through the whole process or whether I'm just asking you what would your initial step be in that process. So my intention is to make it clear, but if it's not clear, then you can just chat me during the exam. And then the main application of this, we're looking at like mass spring problems. So this was similar to work that was on your last homework assignment. And I think that takes us up to where we're at now. We did start stuff on Wednesday on systems of differential equations, but that material won't be on this exam. Okay, so that was big, or maybe a rather fast trip through all of this material. But any questions as far as the content goes?
I do have a quick question about homework 5. Will we be receiving our grades, or will we be getting the solutions for homework 5 prior to the exam?
I can certainly give you the solutions. I don't know if the grading will be done before then. She is grading them this week. So I'm not certain if she'll have them completed by then, but I will put the solutions up right after class. Yeah.
Thank you.
Yep. Okay, so there was a question about partial fraction decomposition, so I've got that on my radar. If there's anything else that people would like to discuss, feel free to shoot them in through the chat, or just raise a hand or unmute yourself. That's totally fine. Yeah, and so just relating to this notion of partial fraction decomposition. Okay. So yeah, there are various cases. So just recall that like you would do this in a case, or maybe we are integrating I don't know, something like this, let's say, with respect to x. Then the idea behind partial fraction decomposition is that we're not able to use integration by parts or substitution on this. Oftentimes, what's helpful is to set the denominator equal to u or whatever letter you use in substitution, and then try doing a substitution that way. But that's not going to work in this case. So the idea with partial fraction decomposition is that we're going to do some algebra first and recognize that the denominator can be factored into, in this case, if I did this right, x minus 5 and x plus 2. Excuse me, x plus 3. And so you recognize that I can factor the denominator, so it's possible to write this as a sum of two fractions, each of which I can integrate separately. And so the idea is we can split up integration with sums. And so if I can break this up into two sums, then I can split it up and integrate each of those. So it really becomes an algebra problem of finding the values for a and b so that when I add these together, I get 3x on top. So I don't want to go through that algebra part, but I do want to go through kind of the general motivation about why this works. And that is, well, once I find these values for a and b, I can then use it to break up that integral into a sum of two things. Each of which of these I could integrate. So that's the gist of integration by parts, just a really quick recap there. And so there was a question about some special cases. So this would be not a special case. This is like a pretty typical case of partial fraction decomposition. So before we talk about any special cases, any questions about this kind of general? Okay, so the kind of thing to be careful about with this, and I can, if these random notes at the end of the slides here are useful, I can post them on Canvas too. And that is, if we had something like this, and I wanted to integrate this, the thing to notice here is that we have this quadratic thing which can't be factored any further, at least over the real. So we're not thinking about complex numbers now. And so when you have a case like this, it's the same idea, and that we're going to, break it up into a sum of two fractions for each of these factors. I put some constant over here. I'll call that C. But you want to be careful. Over here, I don't just put A on top, but what should go on top when we have a quadratic in the bottom?
AX plus B.
Yeah, so one thing to keep in mind is the thing that you put on top is always going to be the degree of the denominator right? It's going to be 1 less than the degree of the denominator. So if the denominator is quadratic, numerator is going to be some arbitrary linear thing. If the denominator is linear, then the numerator is just a constant term. And the algebra in solving for these undetermined coefficients is quite similar to the method of undetermined coefficients, actually. So that's kind of maybe one case in terms of that's a little bit different than the previous one that we looked at, because this one has a quadratic factor that can't be factored any further. So any questions about that case? And maybe there's one last one that I just want to touch on. Yeah, so the last case might be if you had to integrate something so let's say we had something like this that we wanted to integrate, and now the special case is we have a repeated factor. Right here. And so this is might be the special case that you're referring to. So I'm going to have an a over x plus 5. I'm going to have a bx plus c over x minus 1 squared, right? Because that would give me a quadratic expression. So the thing on the top should have 1 degree less than that. And in this special case, when we have a repeated root, we also need to consider that we could have a term that looks like this in there as well. And if I were to add these 3 fractions together, their lowest common denominator would be exactly the denominator that we started with. So that's kind of the motivation there. We want to think about what are all of the fractions that I could add together that would have a lowest common denominator of the fraction we were given in the integral. Okay, does that answer questions about that special case? I think that handles everything that you might see. So it's going to factor. It might be a bunch of linear factors. It might not. And you might have some repeated factors, but now you know how to deal with those repeated factors. Sorry that my chair is so squeaky. I hear it all the time in the videos. Okay, so there was a request to take a look at some question 6A from the review sheet. So that's next up on the agenda. And if you have any other questions, please just shoot them in. I think the easiest way might be to just chat them in, and then I'll see them on the side. Okay, so let's see. Let me open up that file. And if you're wondering what I'm about to open, I'm just opening the set of review problems. which is this. Okay, so yeah, so this was 6A over here. This was the question. Okay. So I imagine the question might mainly be about implicit differentiation. Yeah, but let's take a look at this. So let me get something to write with. I'm just jotting the problem down so I can close this and use my iPad. Okay, so the problem was, here's this equation, and we want to show that it's a solution to the differential equation on the bottom. So that means we want to take this suggested equation and then substitute it into presumably both sides of the differential equation. There's really only one side here. So we plug this into the left side and see if we get 0 on the right side. And so that means, well, I know what to plug in for y. And the question is, well, I would need to know what to plug in for y prime. And since I can't take this equation up top and solve it for y, then the only way I'm going to be able to find a derivative for this would be to find an implicit derivative. So we're going to take the derivative of both sides. With respect to x. And then we just need to be careful that anytime we see an expression that has a y in it, we're going to have to do implicit differentiation. So just to do a little bit of scratch work, if we were to take the derivative of x times y squared, that's a product, then we're going to take the derivative of x with respect to x times y squared plus x times the derivative with respect to x of y squared, right? We would use the product rule on that, treating x and y squared as two different functions. When we take derivatives of x, we do them normal. Derivative of x is 1. And when we take the derivative of expressions for y, then we take the derivative of the outside function, which in this case would be, we take the derivative of y squared, and then we multiply that by dy dx, or y prime, whatever notation you prefer to use. So that would be the derivative of the product x times y squared. Questions about that? Okay, and then let's take a look at the next term, which is e to the minus y, and then I think the others are pretty straightforward. If I want to take a derivative of this, right, this is a, excuse me, a composite function. So we would want to use the the chain rule on this. So we could say, for example, sorry. I'm not saying you necessarily need to show all these steps, but I'm just gonna show it here in case you're curious about the details of this. Okay, we're just gonna say the inside function is y. We don't know what that is. And so then when we take the chain rule, we're gonna take the derivative of the outside function with respect to y. So that would give me like a minus e to the minus y. And then we take the derivative of the inside function with respect to x. And that's why when we do these implicit derivatives, we always see these times dy dx. That's just really holding the place for derivative of the inside function. So this derivative would be minus e to the minus y times dy dx. Okay, questions? So, right, we were kind of sitting up here, taking the derivative of both sides. We did this one with the product rule. We did that one with the chain rule. What's the derivative of 1 with respect to x? 0, thank you. And then on the right side, we still need to take the derivative, but this would be 1 times dy dx on the right side. So using everything that we just found, we have on the left side y squared plus 2xy dy dx minus e to the minus y dy dx, and then the other derivatives were this one, which is 0, so we don't have any additional term, and then on the other side we have dy dx. So that's kind of the calculus step of the process, and then the rest of the process is an algebraic process. So the gist with implicit differentiation is we first take the derivative of both sides, and then step 2 is solve for dy dx. Solve this equation for dy dx. And the way that you typically do that, if you have more than one dy dx term, is you group all of those terms together on one side, and you group all of the terms that don't have a dy dx on the other side. So in other words, here's a term with a dy dx, here's another one, and here's another one. I'm going to move all of those to the same side and then bring the y squared to the other side. So I'll bring that dy dx that was on the right side over, subtracting it from both sides. And then I'll bring the y squared to the other side by subtracting it from both sides. And then we're gonna factor out a dy dx from both sides. We were working with this. So now I'm gonna factor out dy dx, we've got 2xy minus e to the minus y minus 1 is equal to minus y squared. So that tells me dy dx is therefore equal to minus y squared, all divided by 2xy, divided by all of that. Any questions? And the initial question was back here. We wanted to show that this is a solution to this differential equation. And I think that you'll see if you plug what we just found in for y prime, what is over here, I think was exactly the denominator that we had in our y prime. So the denominators would totally cancel out. In the numerator was minus y squared. You'd have minus y squared plus positive y squared equals 0, and it would check out. Okay, so I'm just looking at the other questions that were coming in. If you have a question about this one, just let me know before we move on. So somebody asked about if I can stay a little bit later. I think I'd already agreed to meet with you, whoever sent that in after class. So yeah, don't worry about that. Okay, and then there was a question. I'll just write it on the iPad here, which is, I think this was in regards to this example that we just did, which is, can I use, I think they meant to write dy dx is equal to minus fx over fy. And so, so this would be in the sense of thinking about moving things around and thinking about this as a, yeah, I mean, you're welcome to use whatever techniques you would like to use in that case. Yeah, well then it works out all good. Yeah, that's fine. That's more of a multivariable approach to it, but that's fine. Anything else? I think that exhausts what was in the queue unless I missed something. Okay, there was just a request to do a water tank problem. Such as this one over, well, I guess you're not looking at this, such as 21 in the homework assignment here. So let me share that with everybody just so you guys can see it. So here's 21 down here. Yeah, so we've got a salt tank flowing in, constant rate, 4 liters per minute. And it's flowing out at 3 liters per minute. And we're given some information about concentrations initially and of the solution flowing in. So take a note of this, or if you've got the document open, that's great. I am going to go back to the iPad. So sorry, I can't share 2 things at the same time as far as I know. I guess I could share my desktop. Yeah, and so for the mixture problems, I'll just say like the main gist for anything, for any quantity, you're trying to figure out at what rate is Q changing, then the idea is to take a look at the rate that Q is increasing, and then subtract by the rate that Q is decreasing. And this is like considered compartmental analysis. And so populations would follow this model as well. Heat models follow this as well. We think about, in that case, the rate that the thing is increasing or decreasing, there's only one component. But with salt tanks, we have things going in, things going out. So we have to take into account both of those things. So here, we'll just let X, I don't think we're given any other letter here. So we'll let X equal the amount of salt in the tank. Okay, and we're gonna measure X based on the units here in terms of kilograms. So that's like the mass of the salt in the tank. T is gonna be time since solution is flowing in. So we're going to calculate the derivative of X with respect to time by looking at the rate that X flows into the tank and then subtract by the rate that X flows out of the tank. And a good check that you can have when you're setting up all these equations is to make sure the units make sense. So we're looking at units of X per unit of T. And so T is being measured in minutes here. So the units of this are going to be kilograms per minute. And so that's what the units of the inflow and the outflow should be as well in order for this to all match up. Kind of the way that this flow in and flow out, there's two components to each of those things, and that's the concentration okay, which is we take the concentration going in and then we multiply by the rate of the inflow. And just to check the units of these things, the concentration would be kilograms per liter. The rate of these flows would be liters per minute. And when we multiply them together, it makes sense that we're getting kilograms per minute. And then we would do the same for what's going out. Okay, which would be the concentration flowing out times the outflow rate. And usually what's the tricky part here is thinking about what is the concentration of the solution flowing out of the tank, because that's the one thing that's not constant here. I believe all of these other values are constant. So then we kind of look through the problem and we're told that the concentration of the solution going into the tank is 0.2 kilograms per liter. That's constant, so that's not changing. That doesn't depend on T, that doesn't depend on X. And we're told that the solution flows in at 4 liters per minute, and that also is constant. And there's no reason why we couldn't consider other cases where the inflow is changing with time, and then that term might depend on time. We haven't seen any of those just because solving them is trickier. And then we've got the concentration flowing out. I will leave that blank for now, times the outflow, which is 3 liters per minute. And so I think the trickiest part of this is figuring out the concentration going out, because again, that's like the one part of this puzzle which is not constant. So the concentration flowing out would be the same as the concentration that is in the tank, right? Because the fluid flowing out is the fluid that's in the tank. And we're going to assume this fluid is well mixed, perfectly mixed, and kind of the salt is uniformly distributed throughout. So concentration is going to be the right mass over the volume, or the weight over the volume. And so in this case, we would say, well, what's the amount of salt in the tank at time t? And that's exactly what we call the variable x, right? So x is telling me what is the concentration in the tank at time t. So we've got an x over there. And that's pretty much the same in all of these examples, right? That x is telling me how much is in the tank at time t. And then we need to consider the volume in the tank. And so in this case, we start off with 100 liters in the tank. So this volume in the tank, it's 100 at time 0, but what's happening as time goes on to the volume? Is it going to go up or down? Give me an up or down. Yeah, volume's going to go up because we have more, it's flowing in at a faster rate than it's flowing out. So it's going in at every minute, we get 4 liters that go in and 3 liters come out. So every minute that goes by, we're gaining an additional liter of solution in the tank. So this volume would look like 100 plus T. And this is what goes in the missing spot that we had over there. Any questions so far? So then our differential equation, if we start to simplify things, would look like I could take the 4 times the 0.2, and that would give me the inflow is 0.8, and then the outflow is the 3 times the x over 100 plus t. And then our initial condition here is we're told that at time 0, there's 100 liters of pure water. So that would mean the amount of salt in the tank is 0. And from this, you could solve this differential equation. I'll just say that this is certainly a linear differential equation. So you could use an integrating factor to solve that. Okay, any questions? So is there anything else that I'm missing online other than homework 5 solutions? I think all of the worksheets, at least the stuff that we've done in class, those should be posted. The other homework solution should be up there as well. The solutions to the review to these problems that we just looked at should be up there. So if you can't find something, just let me know. This you can't find apparently because I haven't posted it yet, but I will after class. Okay, so I'll stop here then. And if you have any questions, you're welcome to stick around for some minutes. I've got office hours tomorrow from 1:30 to 2:30. If you do have any questions about that, feel free to stop by office hours. Otherwise, I would say on Wednesday, if you can, it might be useful to try and come to class a little bit. I mean, not like half hour early, but maybe 10 minutes early or something like that. And I'll kind of go through the instructions, most of the stuff that I already said today to start things off before class starts, just to make sure anyone that wasn't here today is clear on what to do. So Cortez, you've got a question?
Yes, I do. Did you get my email?
I don't know. Yeah,
I sent it last week.
We can chat about that afterwards. Yeah. Okay. Well, good luck studying, everybody. If you have any questions, let me know. Otherwise, I will see everybody. Definitely see them all in Zoom on Wednesday. Maybe try and get there 10 minutes early, 10:50 or so. Okay, thanks everybody. Have a nice afternoon. Feel free to stick around.
Thank you.
Yep.